In this video, I'm going to show a few examples of how to take trig derivatives, some of which require the use of the chain rule. We're going to start with looking at the derivative of sine. And the derivative of sine x is equal to cosine x, and that's something that you just need to memorize. But what I would like to point out is that the argument in this example here, the argument of sine is just x, and the derivative of x is 1. So if you want to, you could think of the answer as being cosine x times 1. Because what we're going to ultimately do in some more challenging problems is take the derivative of sine, which is cosine, but then we're going to multiply by the derivative of the argument. And in this case, since it was just x, the derivative of x is 1. This will make more sense in the next few examples. So if we look at 1a, the problem is y equals sine 10x. If I want to take the derivative of this, the derivative of sine is cosine 10x. But then I need to multiply by the derivative of the argument. Now the argument is 10x, and the derivative of 10x is 10. Now I'm going to clean that up by writing the constant out in front, and I end up getting that the derivative is equal to 10 cosine 10x. In number 1b, the problem is y equals sine of 10x squared. Now, we're going to see a few problems that look very similar but are different in the way that you treat them, and these are the ones that have exponents. So in a problem like this, what I think I'd like to do is actually square out the argument. So before I take any derivatives, I'm just going to rewrite the original problem, and I'm going to rewrite it in the following way. Y is equal to sine, and I'm going to ask myself, what is this argument squared? What is 10x squared? Well, this turns into 100x, and now I'm ready to take a derivative. This looks a lot like 1a. So the derivative of sine of something is cosine of that same thing. So this is going to be cosine 100x, but now I need to multiply by the derivative of the argument. So the derivative of 100x is 100. And if I clean that up, we get y prime is equal to 100 cosine 100x. Okay. In the third example, the power 2 is representing squaring the entire trig function. I'm going to do a maneuver here that you must do every time you see an exponent here. So if you ever see an exponent here, what you're going to need to do is rewrite the problem. I like to use brackets. And then I like to write that power here. These two things mean exactly the same thing. But in terms of taking a derivative, it's a lot easier to think about it in this form than the original form. Okay, so for this I'm going to use the general power rule. So to take the derivative, the power of 2 is going to leap down in front. I'm going to write the expression on the inside over again without changing a thing. So this is going to be the sine of 10x. The power of 2 is going to drop by 1, in this case to a 1. And now I have to multiply by the derivative of the inside. Now the inside is sine 10x. The derivative of sine 10x is cosine 10x. But then you have to use the chain rule again and multiply by the derivative of 10x, which is 10. So there's a lot of stuff going on here. Let's clean this up. The 2 and the 10 that are in the front and the back make a 20. And then I have sine 10x and cosine 10x. Okay, now I can take this a step further. Many teachers might accept this as an answer, but I also happen to recognize that this is going to be an illustration of the double angle identity. So I'm just going to remind you of that down here. The sine of 2 theta is equal to 2 sine theta cosine theta. So what I'm noticing here is I see a sine 10x and a cosine 10x, the sine of something and the cosine of something. So to me, that's indicative of this double angle identity. So I'm just going to take this a little bit further, and I'm going to write this as y prime is equal to 10, then times 2 sine 10x cosine 10x. And now it's looking a lot more, the stuff that are in the brackets are a lot more similar to what's written here in green. So what the formula over here in green tells us to do is that if this happens, we can write it in this much more simplistic way by just taking whatever theta is and doubling it. So I'm going to write the 10. This all is going to become sine. The theta for this problem is 10x, so I'm going to double that, and I'm going to get 20x. So this is a much more simplified and concise way of writing the answer than this first version up here. But again, some teachers might say that this is fine, but if you looked in the back of the book and saw something like this, now you have an idea of what the transition was to get from this to that. And one more comment, you could graph both of these on the graphing calculator to convince yourself that the graphs are the same. So you could make this y1 and you can make this y2, and the graphs should be the same. Now we're going to look at a few examples involving the derivative of cosine. The derivative of cosine x is negative sine x, and you just need to know that in order to do these problems. In number 2a, we're asked to find the derivative of cosine of x to the fifth. So the derivative is going to be negative sine of x to the fifth times the derivative of the argument. Now the argument is x to the fifth, so its derivative is 5x to the fourth. So cleaning this up, we end up getting that y prime is equal to negative 5 x to the fourth sine of x to the fifth. In B, our problem is y equals cosine of x to the fifth cubed. The first thing I'm going to do is a little work on the front end by just cubing the argument. So y is equal to cosine of x to the 15th. Remember that when you raise a power to a new power, you multiply the exponents. Okay, now I'm ready to take a derivative. So the derivative of cosine of something is negative sine of that same thing, but then we have to multiply by the derivative of the argument. The argument is x to the 15th, so that's going to become 15x to the 14th. So y prime, when cleaned up, is going to equal negative 15x to the 14th sine of x to the 15th. Finally, we have y equals cosine cubed x to the fifth. Again, this is perhaps the trickiest of all. Whenever you see the exponent written here, it's critical that you rewrite this in a different way. And that is, well, what I like to do is I like to make brackets like this, and I like to say cosine of x to the fifth, and this whole thing is being cubed. So I like to take that power of 3 and I like to write it on the outside. So just sort of train yourself to do that every time you see it, and you should be fine. Now when I see this problem, I'm thinking general power rule. So the derivative is going to be 3, which will leap down in front. I'm going to write the stuff inside the brackets over again. Cosine x to the fifth. I'm going to drop the power from a 3 to a 2, and now I'm going to multiply by the derivative of the inside. The derivative of cosine of something is negative sine of the same thing. But now I need to multiply by the derivative of the argument, which will be 5x to the fourth. Cleaning this up, we get y prime is equal to, we have the negative from over here. We've got a 3 and a 5, which is 15. Let's see, 15x to the fourth. So we took care of this. Now we've got sine x to the fifth. And now we have to write this, and I might put the power of 2 back in this position, times cosine squared x to the fifth. So certainly letter C is the most problematic of all. It's a little bit confusing. So as we do these examples, really focus on problem C, because those are the hardest of all.